In the last video, we saw how you can draw the graph of a linear function, but you can graph any function. Suppose we have this value of x. We can draw this point here at a height of f of x to represent the value of this function at x. Well, we could do it for this x as well, and this one too. We can do it for all the different values of x. Once we've done it for every value of x, we're going to have a curve that goes through these different points. This curve is comprised of every point x and y. Remember, y is on the vertical axis and x is on the horizontal axis. So this graph is going to be comprised of every single point x, y, such that y is equal to f of x. This right here is what we call an equation. We use the word equation because we're equating what's on the left side to what's on the right side. But equations don't have to be as simple as that. It doesn't have to be just that y equals f of x. For instance, it could be that xy squared plus 3 is equal to x squared minus 1. So what do we do with these types of equations? Sometimes we find that it's helpful to transform one equation into another. And that's particularly so when we want to express one variable in terms of another. So in the first equation we saw, we wrote y equals f of x, so we can express y in terms of x. In the second equation, y wasn't expressed as a function of x. So we might want to manipulate the second equation into one that looks more like the first, so that we can take an equation that doesn't express y in terms of x and turn it into one that does. How do you manipulate these equations? What you can do is you can make any changes you want, but you have to do it the same way on both sides. Well, what do I mean by changes? What can you do? Well, you can add, you can subtract, you can multiply, divide, you can take an exponent or a root, you can do whatever, you can take a log. Let's take this example that we started with. Xy squared plus 3 equals x minus 1. And we want to manipulate this equation into something that expresses y as a function of x. So it looks like it's of the form y equals f of x. Remember, you can do whatever you want to this equation as long as you do it to both sides. So you can add, multiply, subtract, whatever. So we can subtract 3 from both sides. So the left side is xy squared plus 3 minus 3. And the right side is x minus 1 minus 3. So we're just doing the minus 3 on both sides. Well, this 3 and this minus 3 are going to cancel. We've got a plus 3 and a minus 3. So those cancel out. And when we have a minus 1 minus 3, we get minus 4. So we get xy squared equals x. And then we put together the minus 1 and the minus 3 to get a minus 4. So we've got ourselves a new equation. Xy squared equals x minus 4. Now what are we going to do? Well, we could divide both sides by x. So if we divide both sides by x, on the left side, xy squared, dividing it by x. Remember, the right side was x minus 4, and we divide that by x. On the left side, we cancel out the x's. That leaves us with just y squared. On the right side, remember that when you have multiple terms in the numerator, so if you have something like a plus b divided by c, you can write that as a over c plus b over c. Similarly, if this was an a minus b over c, you could write it as a over c minus b over c. So here we've got x minus 4 over x, which is x divided by x minus 4 divided by x. Again, here the x and the x are going to cancel, so that becomes a 1 minus 4 divided by x. So we've turned this equation into this one. Remember, the goal is to express y as a function of x. So what could we do next? Well, we could take a square root on either side. If we take a square root on either side, we've got on the left side, remember we had y squared, so now we have the square root of y squared. On the right side, we had 1 minus 4 over x, so we have the square root of 1 minus 4 over x. The square root of y squared is just y. So now we've accomplished our task of expressing y as a function of x. So if we were to write f of x equals square root of 1 minus 4 divided by x, we now have an equation of the form y equals f of x.